So I will talk in the beginning now about Kong and gateway and mesh. Just to make here a foundation on what we are talking, that's the only real slide I will show is explain what the gateway is, what the mesh is, and how they work together is the key thing here to understand in this demo today. Let's talk first about your internal services. I just saw on the survey, the majority of the calls are internal services. So how do we secure internal services in your network infrastructure? How to make that connection secure between your internal services? And the idea here is that every service in a service mesh gets a so-called data plane. So every service gets surrounded by a data plane. Those of you already having worked with a service mesh or Kubernetes might know that under the term of a sidecar. The reason for that is it's deployed on the same pod. In the world of Kubernetes, it's not limited to Kubernetes, but in the Kubernetes world, it would be on the same pod, meaning that jump here from the service to data plane is a local host jump, so no network latency added here on that one. And it's also working here as a transparent proxy. That's the reason why it's surrounding the whole service. So what happens now is that the actual service thinks it makes a direct call to the other service and gets a direct response. In reality, the service mesh catches up the call, applies some policies. Most important are the ones about MTLS, so encryption of the traffic and making it sure that it's really originating from the right caller, logging, monitoring, rate limiting, all those things are then decided here on the data plane. Then it goes over the wire to the other internal service where the other data plane fetches it, checks once again, right sender, rate limit, logging, whatever it does, and then forwards it to the other backend service. So for the service, it feels like there's nothing in between because it's all automated. Important for developers is here that they don't need actually to know that there's a service mesh in play because they just think they make the actual call. That is then what you then will grow with in your infrastructure. It's not about two services, so it's more about that you have more and more services talking to each other, and you can then make decisions based on all those services. And as you are now talking about on a service level, it's not limited to APIs. APIs is the most used use case so far, but it's also about any TCP layer 4 traffic, UDP, whatever you have in place there. So in my example, you see here the front end service. Is allowed to make a call to the backend service, but it's not allowed to make a call to the database because the mesh is already saying no to that call. But it is allowed to make a call to the backend service. That all needs to be somewhere configured, so somewhere you need to specify which policies apply, which permissions are available in your system, and that's the so-called control plane where you define all those policies in place, and that's what is called a mesh. And the mesh, and that's hence to our title of the talk today, is what is nowadays also called as the east-west traffic because it's going from the left to the right and right to the left in your infrastructure. So that's your internal mesh with all your services. When you have that in place or when you're applying that one, there's a second use case now. What about our customers? What about our partners? What about our external consumers? They come from the outside world and they want to get access to, for example, your front-end service. And to do so, you need to something at the edge of your mesh. Something needs to be listening on the edge of the mesh and accepting the call. Once again, validating. In this case, it's less about certificates. It's more about something like a JOT, OpenID Connect, API keys, a developer portal. All those things are applying here to the outside world. And so the consumer comes in, makes a call, provides a token, gateway validates a token, gateway makes logging also on that phase, and then forwards the call into your mesh in here. And the gateway itself is also part of the mesh. So it also has a data plane. It's open to the outside world, but internally it also has a data plane to gain a certificate. So it also can be part of the mesh and then forward that call. And it's also part of the permission structure. So you can also define that the gateway also is not allowed to make a call to the database, but also to the front-end service. And that is where we come to the term of north and south. It's coming from the north part and going to our south internal infrastructure. That is what we want to look today. We want to look at both of that in a live demo. And I will start now here with explaining what we have prepared for you as a demo application. We want to see something similar to that in a real-world environment. So we do have here a demo application running. That is our Kubernetes cluster here. And that Kubernetes cluster, we do have a front-end application. That front-end is then making calls to backends, for transactions, for my profile, as well as for orders. And from the outside world, we are seeing a Kong gateway where we then come from the outside world and want to access that in our system. That's our demo application. And that's how it's from the structure. And it looks like that we can just have a look at it. That's our front end, where it is Bangkok companies there, where you can click on transactions in here, and you get a response from the backend of the transactions. And here you see the orders here, and can access your orders, and you can go to your profile and see that you are not logged in right now. So let's talk about this not logged in. So we have here a fully open website. Nothing is protected, and that's already the first use case we want to tackle, which is we want to make sure that on that part here, if there's someone wants to open that front end, the Kong gateway should secure that before it's going to our front end service. To do so, we do have here a Kong gateway installed, which we can see here in our user management interface. That's our Kong gateway running in front of our system. In fact, it's installed as an ingress controller in our Kubernetes, but it's the full Kong gateway. So you can see there has been some traffic recently. I can see here are some services already existing for the front end, the transactions, and so on. You can see what we have just talked about. We can see we have here the Bangkok application running. We have here a mesh part. We have an API part. So we have different ways of accessing our system. And now we want to secure that in our gateway. What we could do, we could go ahead and say we want to make sure that our front end is secured. Where's our front end? It's the one running on Bangkok on /. We could go ahead and say we are applying here a plugin, and could enable here a plugin for authentication, for access control list, and all those things here, which are available when using Kong Enterprise. But we are living in a world of automation, of DevOps, of CI/CD, so we don't want to click anything. We want to automate all those things, so we want not to make someone making mistakes in a manual way. And that's one of the key features of the Kong gateway. Everything can be automated. As we're running here on Kubernetes, we can be used as the ingress controller, and we are also here installed as the ingress controller on our gateway. So we are using native functionalities of a mesh, of a Kubernetes, so we can invoke like something like an ingress. So I do have here some ingresses as examples. So I could, for example, apply one where I see for that transactions API, I want to apply a rate limit, or let's say we want to create the ingress including an OpenID Connect integration. So that's a standard resource of Kubernetes. We are talking about an ingress resource. We are saying you're listening on bangkok-style.sa on /. Exactly, that's our front end, which we are forwarding in here. And next to what you already know about ingresses, like the standard Nginx from out of the box, we can also apply now our plugins. We can now, for example, say we want to have OpenID Connect applied, and that's what we see up here. This is the configuration on what we want to have. So I do standard stuff here and saying I want to apply the ingress with OpenID Connect. Kong, the gateway, is fetching up that configuration and will apply that here in our system automatically. See, now here we have OpenID Connect being enabled. So let's go to our front end and reload in here what we have. And you now see I reloaded, and I'm now immediately sent to my central IDP, which in my case is a running Keycloak installation. It could be Active Directory, it could be Auth0, Ping, whatever you have in place there. And now I need to first authenticate before I get access to my front end, which makes more sense in a real world use case. So I'm authenticating here, getting access, and it's also secured by a hardware token, which I now have to unlock. And now I'm back to my system, and I still can access everything here, like my transactions again. But the big difference is now I can also go to my profile and can see I am logged in. I have a username. I do have a token, which has been validated by Kong. So we're getting a token by the Keycloak. Kong, the gateway, authenticates that and then checks everything in there. And that's the idea of the north-south traffic. So we make sure that who's coming from the outside world is not doing nasty things. It's not attacking us. We can apply rate limits here to make sure there is no denial of service attack, and all those things which you have seen probably by many gateways and ingresses in here, with a long list of available out-of-the-box plugins within our solution. So let's talk about the second step. Yeah, we do have this running here now in our gateway, but what about the traffic within our mesh? Yeah, what about the communication from our front end, which we see all the time, to the transactions backend service? Those are actually real running services in our Kubernetes, and I can just show you that here in our Kubernetes cluster that we do have it. Where is it one? Here, that is the Kubernetes cluster we are looking in, and I do have here the Kong gateway running in its own namespace Kong Enterprise with 2 containers, and then we do have here the different front end and 2 backend, the transactions one and the orders ones being applied. And you might notice they have two dots, one of them being the backend itself, and then we have the so-called sidecar, which is in fact the data plane we have seen previously. So they are all part of our mesh. And the only thing me as a developer I needed to do is I applied my standard application, my standard services definition, and the mesh is auto attached to them. So if I spin up a new container in there, they will get automatically be part of the mesh. So what can we do with that mesh now? We can first of all get governance and insights on internal traffic. So we can look in our mesh, that's our user interface for the mesh, where we can see we do have one mesh. And right now we are logging to a file beat, we are tracing the zipkin, we have some metrics enabled. We can see which services do we have, and we can see we have the backend, Bangkok frontend orders and transaction services up and running, and they all get their sidecars attached to them, so we can get more insights into what is actually running in there, where they are running. If you're looking here on all the typical data planes, we see here that our front end, for example, is running right now. It's online. It's listening on port 80 so far. We can see that it has a service name and so on. So we can now get a first thing, full governance observability on what is ongoing in our installation. And with that, we can do it here in our user interface. Yeah, but we can also export that to external monitoring solutions. So for example, we just have seen elk was on the list. I do have a zipkin. And with this zipkin, for example, what we can get is here, we are getting a full insight on what is ongoing in our mesh and how the calls are going. So that is our Kong gateway. The Kong gateway has done some calls to our front end, and the front end has done some calls to my backend for transactions as well as for the order. So I'm really seeing how is traffic flowing in my internal network infrastructure. And if you wonder what is that one here, yeah, there's also another one which I can directly invoke. So I have also exposed here an API where I can directly access my transactions without the need of going through a front end. So we can see all the traffic in our network from A to B to C and can see where something going wrong, where is the latency, where are error rates from a very nice overview in here. And if you prefer Jaeger or a zipkin, or if you prefer an elk stack for monitoring with tracing enabled, whatever you have in there. So that is the idea here of the mesh getting observability. You can also have a Grafana dashboard where you see all the traffic and latencies and so on. So that's about the governance, getting idea on what is running in our mesh. Next to that governance, we can also make decisions based on permissions and other things. So if you look here at our mesh, yeah, we can do some things like traffic permissions. We can define, and that's something which I would normally not do on a demo. That's specific because we have Styra today on the call. Today, I'm just allowing from any service to any service, everything. Yeah? I say in the mesh, everything is allowed. Normally, you would strip that down. Yeah, I would strip that down and say I'm allowing from front end to transactions, but not from Kong to orders, for examples. For this demo today, I'm allowing everything because we want to make here something else in place. But before we look at that, what else could we do? We could put in here timeout policies. We could, as I said, logging is already active. We log everything to our elk stack. We have seen we have also tracing enabled and logging everything to our zipkin. But we can also put in here rate limits. I have no one. We can also have circuit breakers. We can work with fault injection. So we can really play with our network infrastructure and make decisions based on the call, what we want to enforce on a per service definition. And that's all very lightweight. You just saw one example from me for permission, but for circuit breaker, it's very similar. Yeah, you just define coming from which service to which service, where you want to have that circuit breaker and how many retries do we want. So it's not a complex thing. It's just that small YAML file which you need to apply, and you will get a circuit breaker for everything with 3 retries, for example, or health checks and so on. So the idea is make it as simple as possible. So let's now see what comes here as the big handover to OPA in here. You know, we have permissions, which are on a service-to-service level, but Open Policy Agent, as we will get in a minute from Adam, is very fine. You can look into the traffic and make decisions based on the headers and contents of the call. So we have also enabled here an OPA policy. An OPA policy, yeah, Open Policy Agent is in there. We have that integrated in our mesh, and we are just configuring here in our policy where to find the Styra server. Yeah, and that Styra server then will inject here policies. Once again, for the sake of the demo, we have just said, please execute everything everywhere in our mesh. You could make that more fine-grained and saying it's specific services where we want to have OPA policies being applied or not. And that's the exact point where I want to hand over to Adam. So we now have a network set up where we have security from the incoming requests from the outside world. We have observability and security in our internal mesh. And now we want to make more fine-grained decisions based on the calls going inside and outside of our mesh, which is the mesh use case. And by the way, just to make that complete, you can also integrate that here on the north-south part. There's also here an OPA plugin. It's already enabled plugins. Here we go. An OPA plugin available here. So if you want to do specific decisions already on the ingress point, you can also use that OPA policy here on the gateway level and also invoke the Styra system here and there. But that's from my point. I will hand over to Adam, and he will pick up that exact same system now and have a look at from his view.
Yeah, thank you, Sven. Hello, everybody. So I'll take it over from here. Screen sharing is working, hopefully. And let me do my own little quick introduction. Styra is the creator of the Open Policy Agent, and our goal is to solve cloud-native policy control or authorization in cloud-native systems. And so let me show you what that means. Oh, and I'm Adam Sandor. I work for Styra as a solution architect in Europe out of Amsterdam. So the difficulty in tackling authorization in any system, and especially cloud-native systems, is that there are so many different points where authorization needs to be applied in some shape or form. For example, we want to authorize our workloads that are getting deployed to Kubernetes, what is allowed and what is not. At the same time, we also want to authorize requests coming into our microservices. But then we might also want to authorize some step of business logic that is happening inside the microservice. So how can we do all these things and still have some kind of common runtime? So that's why the founders of Styra created the Open Policy Agent, which is in the end, a quite simple program that does policy evaluation based on its own policy language that we'll see in a moment. And basically the idea is that OPA becomes the building block of these authorization, of the authorization of different kinds of systems. And how that is achieved is that OPA is, let me just jump to this slide and then go back, because why not? OPA is a very versatile program that can basically, it's just a small Go application that can run anywhere, and it loads a piece of policy that tells what is allowed and what is not allowed, add to that some JSON data and when needed, and the service querying OPA will be sending in basically queries as YAML data, and we'll be receiving decisions back also as YAML data, JSON data. Well, could be YAML too, but like JSON is the so the queries are in JSON format, and also OPA sends back some decision and data also in JSON. So basically, that is all a service needs to do, is to send in data to OPA, and then the Rego policy will be making decisions. In the case that we will be discussing today, we will not have the service directly called OPA, but the service that will be calling OPA will be the service mesh, in our case Kong mesh or Kuma. So the service mesh will be making calls to OPA, and OPA will be making decisions on whether to allow that request to be forwarded to the microservice. It's really important here. So if OPA says no, then basically the client making the call to the microservice will receive a 403. So then the request will be denied. So we'll be doing all the authorization basically on the network level today. And to go back here, finally what you will be seeing today is we'll be using the Styra DAS UI, the Declarative Authorization Service of Styra, which is used as a central control point for all the open policy agents deployed in the environment. In our case, we will be only focusing today on this one use case of microservice authorization in integration with the Kong mesh. And we'll be using the Styra DAS UI to create policies and deploy them into the open policy agent. And once the policy is deployed into the open policy agent, it is running fully autonomously. It will only be polling Styra DAS for new policy. That's the communication, and it will also be uploading decision logs for validating what's happening in the environment, basically for auditing reasons. Finally, just a few words about OPA. OPA is a CNCF graduated project, so it's fully open source project that has graduated in 2021 and has been a sandbox project in 2018. And it has seen massive growth in the past years, both in terms of downloads, Slack users, GitHub stars, all of it. So Styra is very committed to building a very functional community around OPA and keeping it an open project that is used by many different companies and organizations around the world. All right. That was the introduction. Let's jump in and let's apply some policies to the Bangkok application. Right now, I need to log in first to the application. One sec. So once I log in, we can check that my account has a JOT token assigned to it, and that's where a lot of information about my user is stored. This is printed in the application here in plain text, and I will open jwt.io to see what's inside the JOT token. This is issued by the authentication system. So basically, this JOT token, issuing and creating this JOT token has nothing to do with Open Policy Agent or Styra. We can see it's basically done by Keycloak in our case, and we can see what will be interesting from this JOT token is the user is an account owner. It has an account owner role. So we will be doing some role-based access control. Also, the user has a geolocation of Europe. So we will make some policies, and that is more attribute-based access control, where we are using some attribute of the user account to make authorization decisions. So it's a European user and has the account owner role. All right, so back to the Bangkok application. Right now, I'm allowed to basically do whatever, and let's jump into the Styra DAS UI, where we will be editing our policies. All the policies in the that OPA uses are written in code. So it fully embraces the policy as code paradigm, where everything that we do is written as code that can be versioned, put into Git, run through a PR process, etc. So now I will first uncomment our first rule here, which is an RBAC-based role, where we are checking whether the user who in the request has the permission to access or has the orders permission. We also check whether the host name is bangkokstyra.com, so the main application endpoint, and the path in the input is orders. So basically this says we deny the request if the path is orders, the host is bangkokstyrasa.com, and the user does not have permission to does not have the orders permission. Now, where does this? Let's first just publish this policy where I uncommented that piece of code. It will take a few seconds for the the OPA agent that is currently deployed, and I have a view here of the application where every service that we are working with, and this now we look at the front end service, has the Kong Mesh sidecar attached to it. Now the Kong Mesh sidecar actually has a built-in OPA agent, and that OPA agent is currently polling Styra-DAS for the policies. So this is a really nice integration we have with Kong Mesh, where you don't need to deploy your own OPA agent running next to the service, but it's built into the to the Kong Mesh. And now that open policy agent is configured to poll Styra-DAS, which is a SaaS service running in AWS, and download policies every time I make a change to the policies here inside Styra-DAS. So let's see. Now I should be denied the orders. Yeah, I am denied. So what exactly happened here? I am going to bangkokstyrasa.com/orders. So that matches, this part matches my deny policy. And what does has permissions do? Has permissions actually verifies that the RBAC data, so I am checking, I have a piece of RBAC data here that says we have different roles. The account owner role actually has the permissions profile. So in my case, the account owner only has the profile permission. It doesn't have the owner's permission. So this piece of Rego code here also has permission, basically declares that one of the RBAC, that the role we are looking for, which in our case is account owner, needs to exist, and it needs to have a permission that is called P, which in our case is orders. Basically, this is passed down from the has permission, where we are checking orders. We are pulling out what roles does the user have from the JOT token. So we will iterate over all the user's roles and check if that role is inside our data structure, inside our RBAC data, and whether it has the permission. I will also enable another rule, which does the same, but for transactions, but it is not verifying on the level of the main application, but we can see that the host name we are checking now is backend transactions, because the front end will reach out to the transaction service. And now we don't want to deny this on the front end, but on the transaction service. And this is basically showing the power of the service mesh and OPA combined, that we can decide based on just attributes in the request on which point in the service mesh are we doing our authorization. Because basically each of these Kong Mesh sidecars have the same policy downloaded into them. They each has their own OPA agent, and each has the policy downloaded. So we can decide, on each of those points, we can make authorization decisions. So if I now go to transactions, we can see that the page loaded, but the backend is not available. And now I go to edit my RBAC data. This data, by the way, would normally in a production scenario not be edited inside StyroDAS, but would be pushed in here through DAS's API or pulled from another service. So StyroDAS is not meant to be like the source of truth for RBAC data. It is only for the data that the policy needs that is deployed inside OPA. So now once this gets deployed, the transaction backend and both the order service should become accessible. There we go. And we go back to orders, and this backend is not accessible. Okay, that's interesting, and I don't have the time to find out why that currently is happening. Finally, I'd like to show another type of policy that is called the attribute-based access control, where we don't have some mapping of permissions to roles, etc. We are just simply using the attributes of the user account. We are checking the geolocation in the JOT token, and we'll say we deny any non-European users access to our services, basically in this case. However, because my user is actually European, has a European geolocation, as we've seen before, I will rather make this that we will deny all European users now, and we'll see that happening. And basically, we are denying access to the full application once this becomes active. So we have seen that basically neither attribute-based access control or role-based access control are fundamental parts of basically OPA and Styra. It is the flexible Rego language that allows us to do both, mix them up, apply them to any of the services in the service mesh. That is the power of combining this authorization with the service mesh. We can do fine-grained authorization based on the user data in the JOT token or any other data that is coming to us in a request. And I haven't seen yet the decision log that we have that beautifully shows the requests coming in to OPA. We can see that for each request that comes to the application, we have a log entry where we can exactly see the input. For example, we can try to debug the backend orders. Why did it fail the orders call to the backend? Why did that fail? We can see that our input here, this is coming from the Kong Mesh sidecar, which is basically under the hood, it's Envoy. We have the authorization token here. We have the path, etc. We have everything here, and then at the bottom we have the result, the outcome that was allowed false with the code of 403. So this is what our policies did, and I can now try to replay this policy again, this decision against our policy, and basically see that actually we had an extra rule here that I thought I will not be showing today, but I am now, that says that the backend order should not be able to be called from the front-end application. This rule actually shows service-to-service communication authorization inside the service mesh. So basically, yeah, this originally was supposed to be that these two services can't talk to each other, but probably some previous iteration of this demo, I changed it to the front end, so I actually show something getting denied. So if I would change the app to be transaction service, then this would be allowed, and we are actually denying communication between two services inside the service mesh, saying these two services should never talk to each other. And the code here is a little bit complicated because of the fact that we are not getting very nice data about the target service that is being called from the Kong mesh, but because Rego is a versatile language, we can actually very nicely implement even this type of rule. So Rego in the end is a declarative language that is made for writing policies based on hierarchical data that is coming in a JSON document. So we can very concisely, very nicely express our policies and basically implement whatever we need. And that was it from me. I would leave some time for questions. Thank you very much for listening.
Yep. Thanks, Adam and Sven, for the great story. I already saw one question on the chat, but I saw that Sven already answered it. Adam, maybe that you also want to give a word of explanation. So the question was if how the Stira mesh relates to the Kong gateway. And
okay, let's go back to this picture.
Yeah, the question was about the Kong mesh and Kuma. Yeah, which was in the chat.
Okay. Yeah. Then I'll leave it to Sven rather to answer it.
As you have just seen, same with Styra. Styra have an open source offering, and then on top, a commercial offering. We also have our open source mesh solution called Kuma, which is also a CNCF project. And then we do have Kong Mesh, which is our enterprise version with enterprise support and more policies being embedded. And the reason why the name differs is because we donated the whole Kuma project to the CNCF, including the name. So we are not allowed to take the name ourselves anymore, even though we are the main contributor to the Kuma Mesh.
I think it's a good time also to point out how, basically, so Styra's model in relation to OPA is actually different. We don't offer like an enhanced OPA. The OPA you use with Styra is basically the normal open source OPA, but we provide a control plane to publish and edit policies for OPA. So it's a bit of a different model.
Yeah.